Question 11.1. If the probability of C is equal to 0.65, the probability of D is equal to 0.4, and the probability of C intersecting D is 0.26, say whether C and D are independent or not. Justify. So when we talk about independent, we need to use the multiplication rule for independent events, which is the probability of C and D is equal to the probability of C intersecting D, which is equal to the probability of C times the probability of D. And if this is true, then the events are independent. So let's check with these values here. So the probability of C intersecting D is given to us as 0.26. Let's work out now the probability of C times the probability of D. So the probability of C is 0.65. Let's multiply that by the probability of D, which is 0.4. That is equal to 0.26. So we can say now that C and D are independent because the probability of C intersecting D is equal to the probability of C times the probability of D. Both were equal to 0.26 there. 11.2. The letters of the word number are randomly arranged into a new 6-letter word. How many different arrangements are possible if 11.2.1 letters may be repeated? So if letters may be repeated, we have a 6-letter word here. So that's going to be 6 to the power 6, and that would equal to 46656 ways or numbers of arrangements. 11.2.2. So how many different arrangements are possible if letters may not be repeated? If letters cannot be repeated, then we use factorial. So 6 factorial, which will equal to 720, or you can say 6 times 5 times 4 times 3 times 2 times 1, which would also give you 720 there. How many different arrangements are possible if 11.2.3 the arrangements must start with a vowel and end in a consonant, and no repetition of letters is allowed? So if we're starting with a vowel, the vowel takes up 1 space out of the 6 there, the first place. Then the consonant they talk of here takes up the last place of the 6. So the first and last places of the 6-letter word are taken. It means there are 4 spaces left in the middle, which any letters could be there in the space in the middle, but those letters can't be repeated, as they said. So for the vowels, if you look at the word number, there are 2 vowels there, the U and the E. So in the place of vowel there, or V, I can write 2. In the place of C for consonant, I can write 4 because there are 4 consonants there, the N, the M, the B, and the R. And in the middle there, the rest of the letters could be arranged in any order, so we go with 4 factorial for the 4 spaces that are missing there. Multiply all of those, and you get 192 different arrangements would be possible. 11.3. There are X black phones and 8 white phones in a safe. James randomly selects 1 phone from the safe. He records his choice and returns it to the safe. He then randomly selects a 2nd phone from the safe. He records his choice and returns it. The probability that James selects 2 phones of the same color from the safe is 68%. Calculate how many black phones are in the safe if the safe is capable of holding a maximum of a dozen phones. So essentially here, we have James who is taking out phones from a safe, and he does this twice. So a tree diagram here is what we need to construct. So the first part of our tree diagram, James goes to the safe. There are X black phones and 8 white phones. So altogether, the total there for the number of phones are X plus 8. That total is very important. So the first time he goes to the safe, he picks a phone. So the first time he can pick, let's say he picks a black phone, the top line there of that tree. If he picks a black phone, that would be x over the total. So the probability of him picking a black phone would be x over the total number of phones, which is x plus 8. So probability of picking a black phone would be x over x plus 8 on the top. And if he picks a white phone at the bottom there, the probability of him picking a white phone would be 8 over the total x plus 8. Okay, so that's the first time he picks a phone. Let's go on to the second time he picks a phone now. Let's say he picks, we continue on the top line there. If he picked a black phone first, we go on there to him picking a second phone. Let's say he picks a black phone again, so that probability will be x over x plus 8. Or if he picks a white phone, that probability will be 8 over x plus 8 again. But let's say he picked a white phone first, and now we go on, we move to the bottom line there. We move along the bottom line. If he picks a black phone now, it's going to be x over x plus 8 there at the bottom. Or if he picks a white phone again at the bottom, it's going to be 8 over x plus 8 at the bottom. Right, so the question wants us to calculate how many black phones are in the safe if the safe is capable of holding a maximum of a dozen phones. But they gave us here a probability that James selects 2 phones of the same color, and that probability is 68%. So if we multiply along each of these 4 lines that we have, the first line we'll have is he picks a black phone and then another black phone. So those 2 are the same color. The second line, if we follow along, he picks a black phone and then a white phone. We don't take that one because it's not the same color. Then the third one, he picks a white phone and then a black phone. We don't take that one because those are not the same color. But the last one, he picks a white phone and a white phone again. That one is the same color. So we can take the first line and the last line because those 2 lines have him picking the same color of phone. So if we take the first line, that's going to be the probability of black and black. Then you add that to the second line, the probability of white and white, and that probability will equal to 68% as given to us in the question. So if we follow along the first line there, the probability of him picking black and black will be x over x plus 8 times x over x plus 8. Then we add that to the probability of him picking white and white. We follow along the last line and get our values. That's 8 over x plus 8 times 8 over x plus 8. And all that is equal to 68 over 100, which is 68%. All we have to do now is open everything out and solve for x algebraically. So let's simplify the first bracket there. We're multiplying 2 fractions. So we will say top times top is x squared over bottom times bottom is x plus 8 all squared. We add that to the second fraction, the second bracket as well. 8 times 8 is 64 on the top over x plus 8 all squared at the bottom. That's equal to 68 over 100. We're adding 2 fractions now, so our LCD, we already have a common denominator of x plus 8 all squared. Add the top, so x squared plus 64 all over x plus 8 all squared is equal to 68 over 100. Cross multiply there. Once you cross multiply, you'll end up with 68 into x plus 8 all squared is equal to 100 into x squared plus 64. Then we can open everything out. So square the binomial on the left, you'll have x squared plus 16x plus 64. Square the binomial, oh sorry, there is no binomial on the right, but we can distribute the 100 into that bracket. So that's 100x squared plus 6400, 6400. Well, eventually you'll need to take everything over to one side, make it equal to 0, put your like terms together, and you'll end up with 32x squared plus 1088x plus 2048. Now I use the quadratic formula here to solve for x, and I got x is equal to 32 or x is equal to 2. Now, which answer do we take? In the question, they told us that there's a maximum of a dozen phones, so a maximum of 12 phones in the safe, so it definitely can't be the first answer. So our final answer then would be x is equal to 2 black phones in the safe.